Okay, picture this. You're driving, right? The car in front of you just slams on its brakes. But here's the crazy part. Before you even have a chance to react, your car has already taken over, braking just enough to keep you safe. Or how about this? Think about a massive heat wave hitting a city. Usually that means a huge strain on the power grid, right? Blackouts. But what if the grid could see it coming? What if it could intelligently reroute power, predict where the demand is going to spike, and stop a huge blackout before it even has a chance to start? And then there's this, a surgical robot. A surgeon is still in control, of course, but the robot is performing the actual operation with a kind of superhuman precision, a steadiness that, well, it's just not something human hands can do. So, a smart car, an intelligent power grid, a super precise robot. These might seem totally different, but they're not. There's an invisible thread, a kind of intelligence that connects all of them. So what is it? What's the secret sauce? All right, let's get into it. The answer? The concept that is literally reshaping our world as we speak is cyber-physical systems. And listen, those things we just talked about, they're not some far-off sci-fi dream. This is a real revolution, and it's happening right now. It's like our whole world is getting a massive upgrade. So what is a cyber-physical system, really? Let's break it down. Okay, at its core, a cyber-physical system, or CPS for short, is basically any machine where computer algorithms are running the show. The easiest way to think about it is this. It has a digital brain, that's the cyber part, and that brain is controlling a real-world body. That's the physical part. And the key here is that these two things, the brain and the body, are completely and deeply intertwined. Now, you've probably heard terms like embedded systems or the Internet of Things, IoT, right? They sound kind of similar, but a CPS is really a huge step up. So think about an IoT device, like your smart speaker. It takes a command, it plays a song. It's cool, but it's a pretty simple interaction. A CPS, on the other hand, like that self-driving car, is in a constant, super fast conversation with the real world. Its digital brain is constantly getting data and immediately telling its physical body how to react. That super tight feedback loop, that deep integration, that's the big difference. So here's where it gets really cool. How do these systems actually get so smart? It's not magic. It's actually a step-by-step process, built up in layers. People often visualize this as a pyramid. You start with the basics at the bottom and build your way up to full-blown autonomy at the top. It really all boils down to 5 main levels of intelligence. Let's walk through them. Okay, so at the very bottom, level 1, you've got smart connection. This is just the system's senses, its sensors, connecting to the physical world. Next, you move up a level and the system starts converting all that raw data into actual meaningful information. Then we hit the cyber level. This is a huge one. It creates a digital twin, basically a perfect virtual model of the physical system. This is a total game changer because it can run simulations and spot problems before they even happen in the real world. From there, we go to the cognition level. The system uses that digital twin to think, to simulate different scenarios, and to figure out the absolute best course of action. And finally, you reach the top, the configuration level. This is where the system doesn't just act, it then analyzes the result of its own action and figures out how to do it even better next time. It's constantly learning and improving itself. And the most important thing to remember is, this whole 5-level pyramid thing, it's not just some abstract idea from a research lab. These systems are out in the wild right now, and they're already changing everything. You can see them everywhere. In the smart grid that keeps the lights on in your house, in the super efficient control systems running our factories, obviously in autonomous cars trying to figure out city traffic. There are even cool projects like MIT's Cartel, which used a whole fleet of taxis as mobile sensors to map traffic in real time. All of this is CPS tech, making our cities work better. And we're really just scratching the surface here. The possibilities are just exploding into these incredible new fields. We're talking about robotic surgery with impossible precision, sending autonomous robots to explore the deep sea, places that are way too dangerous for us. Heck, even farming is getting a CPS upgrade. You've got projects like the distributed robot gardening at MIT, where actual robots are looking after plants. But you know, for all these massive world-changing examples, the smart grids, the robot gardens, they're all based on the same fundamental ideas that power maybe the most common, and you could argue most powerful, cyber-physical system of all. And it's one that pretty much all of us use every single day.
Yep, it's the phone in your pocket. Your smartphone is a perfect, pocket-sized example of a mobile cyber-physical system.
I mean, just think about it. It's got a powerful processor. That's the brain.
It's packed with sensors, a camera, GPS, accelerometers, light sensors. Those are all it senses. And it has tons of ways to communicate, right? Wi-Fi, 5G, Bluetooth. Put it all together, and it's this amazing device that lets you interact with the physical world around you in incredibly complex ways, all through the apps on your screen.
So when you take a step back and look at the big picture, from the massive citywide smart grids all the way down to the phone in your hand, it's impossible to ignore. We're building a future where the line between the digital world and the physical world is getting blurrier and blurrier. And the upside here is huge. We're talking about massive gains in three big areas. First, safety. Cars that just don't crash. Second, efficiency. Imagine buildings that produce as much energy as they consume. And third, we're even augmenting our own human abilities through things like incredible new healthcare monitoring.
Now, of course, it's not all easy. Building this future is a huge challenge. One of the biggest roadblocks is just getting everyone on the same page. You've got software engineers and mechanical engineers who kind of speak different languages. Getting them to work together seamlessly to build these super complex systems, that's a tough nut to crack.
But the good news? The progress here is relentless. Every year, new advances in science and engineering are making that link between the cyber and the physical even stronger. That means these systems are constantly getting more adaptive, more autonomous, and more reliable. So let's leave it with this thought. The big question going forward isn't just about what this amazing technology can do. It's about what we as people should do with it. As our world gets undeniably smarter and more connected, how do we make sure that it stays, human? That might be the biggest challenge of all.